through all that again. Okay, so the section that we're starting on after that little review then is this last section here where we need to find the angle. Okay, so we're going to reverse the process. Previous problems have shown us that if we know the lengths of the sides of a right triangle, we can find the ratio of the length of the side compared to the hypotenuse, the ratio of the length of the adjacent side compared to the hypotenuse, that's the cosine, and the ratio of the length of the opposite side compared to the adjacent side. I hope you're starting to get used to by now the understanding or the intuitive nature of thinking about these things in terms of ratios of lengths of sides, okay? This side is half as long as this side. This side is 6/10 as long as that side, okay? So these are all ratios here, right? And then if we know the length of a side and an angle, we can find the lengths of the other two sides. So we've started learning that skill, okay? We also stated that for any non-right angle of a right triangle, whether it's 1.7 or 59.6 or 74.3, whatever that angle, for that angle, there is one and only one sine, cosine, and tangent that corresponds to that angle. Therefore, for a given value of sine, cosine, and tangent, there is one and only one angle that can correspond with that value. So if I have a calculator or a trig table, and I know what the value for the sine, the cosine, or the tangent is, I can calculate one of these values using the lengths of the sides. I can find the angle by the inverse, finding the inverse of that function. Okay? So the basic strategy is this. Given two sides of a right triangle, or given information that will allow me to calculate the sides of a right triangle, Same starting point. I'm going to label the triangle. Then I'm going to do the same thing I did before. Related to the angle I want to find, what two sides of the right triangle do I have? Do I have the opposite and the hypotenuse? Do I have the adjacent and the hypotenuse? Or do I have the opposite and the adjacent? Then I ask what trig function contains both of these sides. Hopefully you've got that the process is the same for both of these. I ask what side do I have, what side do I want for the other. That tells me the trig function. Here I ask what two sides do I have. That tells me the trig function. Then you're going to write down the standard formula for that trig function, remembering to include the symbol theta after the name of the function. Then you're going to move the name of the function to the other side of the equation in front of the ratio for that function and place a superscript -1 after the name of the function so that just theta is on one side of the equation and the inverse designation for the trig function, its ratio, are on the other side. Okay? That's the difference in this strategy than the other one. Then we're going to substitute in the labels on the diagram, and then we're going to plug in the values, and we're going to solve. So in these following problems, find the requested angle. The first one's been done for you. The remaining three I've given you no additional help on. So for this angle, okay, and let's just go through this without the actual help down below. Find angle theta 1. I want to find this angle right here. And so I'm going to ask myself to, well, actually first I'm going to label the sides, right? I'm going to say, let's change the color of that. I'm going to say this is the, and so we want it with reference to angle theta 1. So this is the adjacent side, this is the opposite side, and this is a hypotenuse. Okay? So I'm going to say, what two sides have I been given? So in this case, what two sides have I been given? I've been given the opposite and the hypotenuse side. Immediately your brain goes sine, right? Sine, S-O-H. So Okay? And so I'm going to write down the definition of sine. I'm going to say sine of theta equals opposite over hypotenuse. But then I need to realize, you know what? I don't want the sine of theta. I can already figure that out. I've got the opposite and the hypotenuse side. I want to know what this angle is. So I've got to reverse this process. I've got to go backwards. And so in order to do that, I'm going to say theta equals the inverse sine, right? I'm going to say theta equals the inverse sine. And we remember that on our calculator, all we need to do to get that is to hit the second button and then the sign, and that will give us the negative sign. And then I'm going to put, or the inverse sign, not the negative sign. Then I'm going to put the opposite over the hypotenuse there. And so now all I'm going to do then is finish this by saying this equals the inverse sine of, and the opposite is 7.78. And since I'm just using the ratio here, I don't really need the units. Divided by 23.9. And somebody should already have that angle. What'd you get?
19 degrees.
19 what?
Degrees.
19 degrees. Okay? Does it look like it's about 19 degrees? It does, doesn't it? So use your understanding of this to check, hey, yeah, that looks like it's about 19 degrees. I think my answer is probably correct. Okay? So if I scroll down, hey, we got the right answer. Awesome job, Kirsten. Okay, so I'm going to ask you to spend the next 10 minutes and figure out the next three. We did that in about 30 seconds, right? All you need to do, again, is say, what two sides do I have? I'll give you some help on this one. We want angle theta 2. I have the hypotenuse and I have the adjacent side, so I'll need to use the inverse cosine there, right? Okay? So, go ahead and spend the next 5 minutes, 10 minutes, and do these last three problems. You're done with them already?
Maybe.
Awesome. Oh, did you do them already, or you hadn't done them already, had you?
No, I hadn't.
Okay.
I just was able to do them.
Once you get this, this is so easy. Once you finally understand this, this is so easy. It's like, I don't know why I had problems with it before.
I don't remember.
I have no idea why.
I remember learning them, but I don't remember how to do them.
We got 2 by 2, 2 by 2, and 3 by 2. No, don't look. What are the other ones?
So we have the adjacent side and then the bottom.
Why don't you do yourself?
Nice try.
Where did you go through?
I'm gonna be honest, I don't know if I'm
Hang up like this right there.
So,
I don't know.
so the hypotenuse is the one that's across from the right. So that's the H.
Oh.
So it's the, and it's always going to be the longest one.
4,
Okay, and so,
4, 2, 4, 4,
the angle you want,
4.
right, you want theta 2. The side next to it is the adjacent side. Adjacent means next to.
4,
And then the side
4, 8.
opposite, so this is A. This is opposite instead of A. Right, because it's opposite of that angle. Because it's across the side. Okay, so now that you know that you've got the hypotenuse in the adjacent side, it's going to be the cosine instead of the sine, right? So okay, so that, but it would be
It was not.
but if what you had before as far as labeling was correct before, that would have been correct.
What?
Adjacent side. Just what you did.
Cosine negative
What's it say? Okay, so how would you label this triangle?
Draw it out on the chart first. Just write HOA, so you remember.
So which side is the longest side?
So you know that's adjacent.
Okay, and that's always going to be the
Good
hypotenuse.
job. I know a little bit.
Okay, and then the side that is next to the angle is going to be the adjacent side. So which side is it? Is that next to the angle? Or is this next to the angle? So this is next to the angle, isn't it? Yes. Okay, so, well, here's the angle, right? And that side's next to it. So that's going to be the adjacent side. So put it on the label. And then this side's going to be opposite because when you look across the triangle, that's the opposite side. So the side that's across the triangle is going to be the opposite. So label that out. Okay, so now, since you want to find this angle, you have to ask, which two sides have I been given? You've been given which two sides here? What values or sides do you have values for? Okay, so you've got values for the hypotenuse and the adjacent. And if we write down our mnemonics, so in TOA, the trig function that has A and H in it is the one that starts with C. So that's cosine. So write down cosine, COS, equals, so cosine of theta actually. So write down the little theta sign. Okay, so that's this sign right here, that symbol. Okay, so that equals adjacent over hypotenuse. So write down the definition. And then we say, well, wait a minute, I don't want the cosine of theta, I can just divide those two numbers. I want theta itself, I want the angle. So now I'm going to say, okay, well, let's rearrange this. So write out theta, so theta equals. Now it's all equals the inverse, so cosine to the negative 1. Okay, A over H.
Like, dog, you're not doing anything to help.
Okay, so I don't want the cosine, I want the theta. And to do that, I have to use the inverse, which is the negative 1. And so I'm going to go to my, so I'm going to say, I'm going to rewrite the cosine to negative 1. So say equals after that. Okay, cosine to negative 1. Okay, and now I'm going to put values in which side of negative 1, and which side of we say is the adjacent side. Okay, so for 19,
We're going to put that now. We're going to university.
then I'm going to go to my calculator, I'm going to get second.
Weird schools that will be
Figuring out cosine.
So there's like random words.
Okay, and see it brings up cosine to the negative 1. Then you're just going to plug those values in there.
University. University
So
of
19
pink
divided
face.
by 4.1.
No.
And then close the
It just starts still random letters.
I didn't know whether it's over.
Conversations were like, they're like, yeah, maybe next year you'll be good.
And that's about 60 degrees, and that angle looks like it's about 60 degrees. So you do the right
He's
thing.
like, oh, how much you bench?
So we have
Goodbye.
the rest of it.
Never mind. He just keeps talking to him when they're just trying to ignore him.
It still says I have 3
Like, hey,
pages.
yeah,
I'm
I'm
just
just
from last
strong
quarter.
Yeah, I don't like it. What's that?
Okay, are you okay? So you're okay. This wasn't what we were working on, though,
This
right?
wasn't?
No, this is. So. So this is what.
He do a back down, so we're like, wait a minute, what is this?
Find angle, so that's the one that I just did. Okay. So.
Doing a make.
Yeah.
Wait.
So I found this one. We're supposed to be working on this.
But on the other hand, so I have a question. So is it always gonna be O on top or O A over H?
So what's your other one? So yeah, go. So right out.
I don't know.
Okay, so right out there, like long. CAH.
CAH.
So sine opposite over hypotenuse, cosine adjacent over hypotenuse, and opposite over base. Yes, it's always going to be that way. Forever, ever. And on your other packet, it has that mnemonic on it. So, it's making sense?
Yes.
Straight in the middle.
More sense than when you did it in math? Or as much?
Yeah, the only reason why they split on offense is because we know gas.
Okay, enough of you are done. Even if you're not done, I'm just gonna go through these and make sure we're all correct up here. So let's just make sure we're all correct. So find angle 2, and actually I need to be using this. So we want angle 2. Okay, theta 2 there. So I asked myself the question, which sides do I have? Well, I've got to label it first to make sure. Remember, the hypotenuse, you can find it one of two ways. It's either the longest side or it's the angle that's opposite the right angle, right? Then adjacent means next to. So which side is next to this angle? And that's this side. Obviously the hypotenuse is next to that angle too, but we've already called it the hypotenuse, so we don't need to call it the adjacent side. And then the opposite side is the side that's opposite that angle. Okay? And all we have to do is say, what two sides have I been given? I've been given the adjacent and the hypotenuse. And we know because of our mnemonics, so, ka, toa, that we have to use the cosine here. So I'm just going to write down the definition of the cosine. Cosine of theta equals adjacent over hypotenuse. But wait a minute, I don't want theta, or I mean I don't want the cosine, I want theta. So I'm going to say theta equals the inverse cosine of the adjacent over the hypotenuse equals the inverse cosine of 219 over 414. And I'll go ahead and calculate that too. Second cosine of 219 divided by 414. And I get 58.1 degrees. Does anybody object to 58.1 degrees?
Do you want just one decimal?
Yeah, I want 3 figures is what I want.
Yeah, I was like, I did too.
That's fine. If you do more than that, that's fine. Okay. Find angle theta 1. That's this angle. Okay? And again, the hypotenuse is the longest side. Now, this over here is the opposite side, and this is going to be the adjacent side. What 2 sides do I have in this case?
Adjacent
An opposite. Opposite and adjacent. Therefore, I need to use the tangent, right?
Yeah.
So I write out the tangent of theta, bless you, equals opposite over adjacent. But I don't want the tangent, I want theta itself. So theta equals the inverse tangent of opposite over adjacent equals the inverse tangent of 191 over 666. Okay? Now, if you know this stuff and you know that the tangent is, if it's less than 45 degrees, my value is going to be less than 1 because the opposite side is going to be shorter than the adjacent side. Therefore, my value for this is going to be less than 1. And if it's a lot shorter, my value is going to be a lot less than 1. So if I find the inverse tangent, well, but my value is going to be a lot less than 45 degrees is what I meant to say. So the inverse tangent of 161 divided by 666 is 13.6 degrees. Theta equals 13.6 degrees. Does anybody object to 13.6 degrees? Is that what we got?
I got 16.
Well, I'm glad you objected then. Oh, because it's 191, not 161, isn't it? Okay, you got what?
16.
16.0. Thank you for objecting. Okay. Triangle 4. Oops. Find angle theta 2. Okay? And I know this is the hypotenuse. This is the opposite side. This is the adjacent side. Hopefully we all got that. And I have been given the adjacent side and the hypotenuse. Therefore, I want to use cosine. And I write down the definition of cosine of theta. By now, hopefully, you figured out what the pattern is here so that you don't even really need to do that. You can just go straight to theta equals the inverse cosine of adjacent over hypotenuse equals the inverse cosine of 7.45 divided by 16.4 and second cosine of 7.45 divided by 16.4 equals 63. 62.98. So we're going to round up, all right? 63 degrees. Does anybody object to 63 degrees? Okay. Hopefully this is significantly easier for you now than when you first studied this. Any questions?